So we're looking at a sum rule. Now my pen. You know what? I'm starting to notice what the issue is here. If I'm recording, that's when it's glitching on the writing. When I'm not recording, it doesn't have any trouble writing. It's a memory thing. Sum rule for sine. All right, so basically I just have to take my A's and B's in that formula and replace them with X's and H's. So limit as H approaches 0 of sine X cosine H plus cosine X sine H. All right, so that's the full-blown expansion. Wait, why does that look like that? That's so weird. All right, so.
Wait, isn't it sine of H cosine of X?
Oh, it's commutative. It's the same thing. Yeah, I tend to write it this way because I like the X's first and then the H's. So I guess I could take that as a typo. Yeah, we could submit that because I like the arguments to be in consistent order. Because you see in the second one, the arguments, the A's and B's are in consistent order. So I'd like them to be consistent here. So they should be cosine A sine B. Yeah. But what I don't understand is why it did such a nice job of highlighting it previously. And then here, okay, now it's highlighting it nicely. Before it was just like smearing it out. That was strange. All right. So now we have this. Now we didn't have to use Pascal's triangle to figure this out, which I guess is good. But you needed something else, which I guess is not good. All right. We don't have to use algebra to simplify this down, which I guess is good. But we got to do something else to simplify it down, which I guess is not good. So, you know, like we got everything going in different types of directions here. All right. One thing that I do notice is that I have a common sign of X. Might as well just group those together. So just try not to overwrite the plus sign. And make its own fraction out of it. So limit as H approaches 0 of sine X cosine H minus sine X all over H. All right, so that's going to be one fraction plus a completely separate fraction of cosine X sine H over H. So you could break up a fraction as long as there's addition, subtraction in the numerator. And you could break it up any way you want. I chose to break it up so that the signs were together, sine of X. All right? And what prompted me to do that? Honestly, I mean, experience now, intuition, calculus intuition, sure, I guess. More so the fact that I've done this problem like 30 probably at least.
36 and a half.
No, I was going to say 30 times before because that's my go-to, but it's definitely well over 100 times before. So there's the experience component of it, but I'm trying to put myself in your position. If I were staring at this middle line, my reasoning for doing this step here would be one of two things. I tried everything else and nothing else worked. Or, well, you know what? I did that because I didn't know what else to do. Right? I see a couple of sine X's, so why not just put them together? Because nothing else matches up. So what else could I do? Nothing else seems to make sense. All right. So when I do that though, things start cleaning up nicely. And that's where you kind of have to have faith in the process. And that's why I'm talking about intuition, because the intuitive part of this leads you down this road and allows you to believe that what you're doing is correct, or at least has a fighting chance of being correct. All right? Because once you get from the second step to the third step, you should start seeing the overall structure of those limit rules from the last unit. I also have those indicated for you here. They're just kind of off on the side. You know, they were their own questions on the last unit test. That's how important they were, right? I put them on the test as gimmies. I wanted you to have a couple of questions that you could get them right without showing any work. That's not to say that like everybody needed to have it memorized. You could always put it in the calculator. But I wanted you to have a couple of questions where you just put down a 1, put down a 0, and just move right along. Right? I always like to have those confidence building kind of questions. All right. So yeah, that's that part of it. But the other part of it is they're that important that I made them their own questions on the unit test. All right. So if that's the case, then they can't go away. They need to be part of your memory. All right. So one of them is the sine h over h. I got a little bit of that over here. Sine x over x, sine h over h. The other is cosine x minus 1 over x, cosine h minus 1 over h. I got that over here. All right, so a lot of good things going on. This is cleaning up very, very nicely. It's just if you haven't experienced a problem before, your calculus intuition is what's going to get you going in the right direction. Beyond that, your experience is what's going to carry you through. All right. Eventually, you'll get to a point where you say, well, I know how to do this one because we've done it 30 times before. All right. But until you get there, how do you tackle it? Well, my spidey sense is telling me that it's got to be like this, because how else is it going to fit one of those limit rules for trig? All right. So this part of it, we know from the last unit is going to go to 0. This part of it, we know from the last unit is going to go to 1. We also learned in the last unit that we don't have to separate it into different limit problems in order to realize that each component is going to go where it's supposed to go. So by actively applying the limit here, all I'm left with is a 0 times sine, that goes away, plus 1 times cosine, and what we just discovered is that the derivative of the sine function is the cosine function. So f prime of x is equal to cosine of x. All right, now, again, I'm going to be hitting you hard with this calculus intuition stuff. I'm going to probably make a sign out of it at some point, because we just figured out the analytic solution. We just figured out that the derivative of sine is cosine. So then, if I were you, I'd be sitting there and be like, cool, what the hell does that mean? Like, how does that equate to anything? Like, so what is a derivative? The derivative is the slope of the line tangent to the curve at any point along the curve. So what we're getting at is the idea that if I were to find the slope at any point along the sine wave, somehow that's going to create a cosine wave. How does that work? Right? So that's where the graphical component comes into play. Right? And then once you have those two pieces together, then you could start drawing conclusions logically for other types of functions. So then you could start saying, oh, I wonder what would happen if there was a negative cosine function versus a positive cosine function. Sine function. You know, so the logical reasoning will come into play, allowing you to draw conclusions that further advance the cause. All right, so the subject of tomorrow's activity is going to help you to understand what that looks like so that you can start putting these pieces together. And with the idea being that if you can develop an intuitive understanding of calculus, that it's just less to study. I mean, you want to put it in like normal human being speak, it's less to study because you have an innate understanding. It's part of you. You don't have to like open a textbook and memorize formulas and things like that. You understand the meaning of it. And once you have the true meaning of it inside, then you're good to go. All right. So what I want you to do is limit as h approaches 0 of f of x plus h minus f of x all over h. The other is the f of x minus f of a over x minus a. That's a good approach to use, I think, for fractional and radical expressions. Sometimes for trigonometric expressions, I find that in this case, there's enough of a workaround that you would have to do that you might not like it as much. All right, so I say we stick to this approach. All right, so limit as h approaches 0. So the first piece is us just taking the x plus h and replacing the x in the original function with that x plus h. So cosine x plus h minus the original function itself given as cosine x all over h. With a hearty cough. All right. Now, this next step is going to require a little bit of prior knowledge. You have it at the top of your page. It's one of those double angle rule. It's one of those expansion rules for the sum of two angles within a cosine function from Algebra 2 and pre-calc. Most likely you were given formula sheets. You didn't really have to memorize them, but you're at the point now where like some of the rules, they should be so ingrained in you that you remember them, and then some of them, like this one, it's like, I don't know that I'm ever going to remember it. So maybe it finds its way into your calculator. You know, like you could just write a program and save it as a program. All right. Ideally, you'd have that program do something for you. We don't want to just have programs just be there for the purpose of storing formulas. We want to actually do some computation for us, but we'll take what we can get at this point. I can say in full disclosure, for complete honesty, that I know I knew that formula for a little while in high school. I completely lost it in college, and then I had to relearn it when I started teaching again. Right? So it's totally understandable if you lose some formulas from time to time. It's completely natural. Right? So what this is telling me is that if I have the sum of two angles within a cosine function, A and B, is going to be the cosine of the first angle times the cosine of the second angle minus, right? This is not a typo. It's supposed to be that way. The plus here corresponds with the minus here. The minus here corresponds with the plus here. Right? So minus the sine of that angle times the sine of this angle. Right? So I'll just rewrite down below so I don't have to scroll back and forth. I'll rewrite the relevant formula, at least in terms of these angles. Cosine x plus h, by definition, so a triple equal sign means by definition, if you don't want to be pretentious like me, you don't have to use a triple equal sign. You could just use a regular equal sign. Cosine x, cosine h, minus sine x, sine h. All right, so again, I don't know why it does that sometimes. Hold on, let me just do this. Just gonna scroll a little bit. Yeah, you see, sometimes it highlights it nicely, And then sometimes it like blurs it out. I don't know. I'm waiting for my Tuesday tips for the Explain Everything app. They give new tips every week on Tuesdays, as you might have gathered. But so far they're like, how do you draw stuff? You tap on the draw thing and then start drawing. I'm like, you're so helpful. So anyway, that is the highlighter. Limit as h approaches 0, cosine x, cosine h, minus sine x, sine h, minus the cosine x that's already there, all over h. Now, a logical next question in your mind would be, all right, now what? All right, that's where logical reasoning comes into play. All right, you got to play it out in your mind sometimes. All right, if this, then what? You know, so you got to think to yourself, and I'll think to myself. What can I do in terms of like how can I reorganize this? Is there some way that I can regroup things to make it make more sense? The only thing I can come up with, based on just at first glance, is that this has a cosine x in it, that's a cosine x. There's nothing else from one expression to another, one term to another, where anything else is in common. I only see one sine x. I only see one sine h. I only see one cosine h. I only see one h. There's no way I could reorganize any term so that some like factors would be grouped together. So I think that's my only avenue. Now, part of the journey here is experience. So there is a component where like, oh, how do you know how to do that? Well, I know how to do it because I've done this problem 100 times before. But there was a first time, and that first time I had to really reason it out. And so sometimes when you're in the process of reasoning it out, you can kind of put yourself in a spot where you're like, I don't know what to write, so I'm not going to write anything. And before you know it, 15 minutes have gone by and you haven't put pencil to paper. Right? Write something. You know, even if you're not sure about it, just write something and erase it later. Get a new piece of paper. It doesn't matter. Right? By now, you should have already come to the understanding that this class is not really as much about tests as other math classes are. Right? I haven't even announced when the second test would be. Right? So, and the fact that like we're middle of October and I haven't announced when the second unit test is going to be, that should give you a sense of where this is going. It's more about the journey. It's not about just taking tests. All right. Can't say that about every math class you'll ever take, but this is one of them. So let's enjoy the ride. All right. So I have a common cosine. I mean, break up the fraction. Give it a shot. Don't be afraid. So break it up based off of the minus sign here. I just want to keep those cosines together. With the idea being that, well, I have a common cosine, so let me factor it out. Somebody likes that term. All right. So I factored out the cosine x. This kind of split it out, pulled it out as a GCF. When I did that, I was left with cosine h minus 1 over h. And then simultaneously with that, I figured, you know, if I'm going to pull out a cosine of x, why not pull out a sine of x? Not necessarily because they're cosine and sine, but because they both have x's in them. All right, get our h expression together, you know, with each other. So cosine h minus 1 over h and sine h over h. Because thinking back to the last unit, and maybe you don't want to think back that far, so think back to the top of this page. Those are rules. Sine of x over x as x approaches 0, so replace the x's with h's. So limit as h approaches 0. Magnetic. Limit as h approaches 0, sine h over h is equal to 1. Limit as h approaches 0 of cosine h minus 1 over h is equal to 0. So, going back to that example below, I now have, geez Louise. I can go to 0 on this one. I can go to 1 on that one. So I'm looking at the limit as h approaches 0 of just the negative sine x. There's no h. There's nothing to substitute into anymore. Everything that involved an h canceled away. That's great. That means that the limit is equal to the negative sine of x. And so what we get from this is the impetus behind what I was saying before.